Good evening. Today we're talking about composite function with three objectives. First, we will learn how to find the expression of a composite function, solve equations using composite functions, and find the range of a composite function. Let's take a look at two functions, f, such as x maps to 3x plus 2, and g, x maps to x squared. You've seen before that x in that case is only an input, so it can be anything. So we can write the function f as f of input equal 3 times the input plus 2. Same for the function g. G of input is the input squared. As we know that, we can put anything in each function. So for example, if I take the function g, whatever I put inside, I will square it. So inside the function g, what I can do is put the function f. So if I put the function f inside the function g, it means that I'm squaring the result of the function f. So I have 3x plus 2 squared, which I can simplify into 9x squared plus 12x plus 4. So I can define my function gf as x maps to 9x squared plus 12x plus 4. The same thing is true for f. So for the function f, whatever I put inside, I will multiply by 3 and then add 2. So if I put the function g of x inside f of x, I have 3g of x plus 2. I can simplify as g of x is x squared, I get 3x squared plus 2. So I can define my function fg as x maps to 3x squared plus 2. What we've just seen is the composition of functions. So composition of function is when we apply one function to the result of another. So if you apply the function g to the result of f of x, we get the function gf. If you apply the function f to the result of g of x, we get the function fg. Let's look at an example. Two functions f and g are defined by f such as x maps to 2x plus 1 and g such as x maps to x squared minus 1. Express in similar form the function gf and f squared. So first let's do gf. We've seen that gf means that we evaluate first the function f and then the function g. So while I map x through f, I get 2x plus 1. So 2x plus 1 is the input of my function g. So when I apply 2x plus 1 to my function g, I get 2x plus 1 squared minus 1. The question asks us to express in similar form. That means as we have here the definition form of the function, we need to express our function as a definition form. So the function gf such that x maps to 4x squared plus 4x. Second part of the question asks us for f squared. F squared here is the composition of f with itself. So basically what it means is that we evaluate f at f of x. Same thing, we ask you to express it in similar form. So you need to use the definition form, which is f squared such as x maps to 4x plus 3. The second question asks us to find the values of x for which gf of x equal g of x. For this, we simply write the equation gf of x equal g of x. We found that gf of x is 4x squared plus 4x, so we can substitute 4x squared plus 4x equal g of x, which is x squared minus 1. Before we move on to the next example, here is your practice problem for the day. Express in similar form the function fg and find the value of x for which fg of x equals 7. We use the same function f and g as the previous example. Let's take a look at another example. Given that the function f is 3x plus 2 for the domain minus 1 to 2, find f squared in similar form and state the range of f squared. The first part is simple. We want to find f squared in similar form, so in definition form. So we ask you to find f of x. We ask you to find it in similar form, so we write it f squared x maps to 9x plus 8. On the second part, we ask you to find the range of f squared. For that, we're going to look at the domain and range of each function of the mapping. So, square, first we map through f, get f of x, then we map again through f and get f of x. If we look at the domain is x between minus 1 and 2. For this domain, the range of f is minus 1, 8. As the function is a linear function, you can find it by just evaluating the boundaries of the domain. To find the range of f squared, we evaluate through f again, but this time our domain is minus 1 to 8. So if we start from a domain of minus 1 to 8, the range of the function f is between minus 1 to 26. Here is your second practice problem. It's basically the same as what we've just done, but this time we have a quadratic function instead of a linear function. To help you solve that, don't forget to make a graph.